tabular integration is not that much different than integration by parts. It's just a more convenient way to write it out so that you don't have to write all that work to the side over and over and over again. With this problem, I said, what if we have x to the fifth sine x dx? How many times are we going to have to do that formula of integration by parts?
More than I want to. 5?
5 or 6 times. If we go through, so I'm going to show really quick what we'd start with. Evelyn, have you watched the video yet?
I watched some of it.
Yeah. So just to show, so don't write this down because we're going to do it the faster way in a second. But we have to pick u and we have to pick v. What was our rule for picking u? There was a little saying that helped us. Lip it.
Something about
So if there's a natural log, we would pick that first. We don't have one, so we skip to inverse trig function. Don't have one of those. We go to p, stands for polynomials, which we do have, so u would be x to the fifth. Again, don't write this down. I'm going to erase it, and we're going to start all over. So just contemplate it.
the answer is 42.
We differentiate on this side. We integrate on this side. So we get
Cosine?
negative cosine.
Why is it negative?
The derivative of sine is positive cosine. So the
Oh, right.
integral of sine is negative cosine.
And it's just a it's like a circle, right?
Yep. Yeah. And then we just combine. We have u times v, so negative x to the fifth cosine x minus the integral of v du. We do have another negative, so plus 5x to the fourth cosine x dx. And then we would do it again. And we're going to have to do it 5 or 6 times. We would do all that information again. We'd take this. We'd say u equals 5x to the fourth. dv is cosine x. And we'd do that whole process again.
Once you do the integral again, you still do the uv minus whole formula?
Yep, you do a whole nother with just this piece, so we
With
would
just that.
still have negative x to the fifth cosine x plus, and then uv minus integral of v du.
So you still have to,
Yep. And we do that whole thing again
You
and
did a
again
lot of
and
force.
again until we no longer have an integral symbol. So we can organize this in such a way so that we don't have to keep rewriting this over and over again. Some people preferred last year just to keep doing the formula. They liked the formula, which is fine. Either way, these are basically the same idea, just 2 different ways to do the same thing. So when we want to differentiate this with tabular integration, which we do need to write down now, we need our u column and our dv column. And we need to remember that the u column is really a differentiation column. dv is an integrate column. So we still pick u and v the exact same way we have been. We already identified what u is, so what will u be? X to the fifth. So we are going to differentiate that until we get to 0. So x to the fifth, 5x to the fourth, we differentiate again, 20x to the third, 60x squared, 20x, wow, I'm running out of room. 20 and 0. fairly improved. So yeah, there's still a lot of writing with this. I mean, we have a fairly long column, but it's still actually going to be less than if we did the formula. So then we still pick dv as our normal formula, or our normal piece like we did before. So it was dv cosine x. And then we integrate it. Didn't I say cosine x? Sine x. Okay. Thank you.
You did.
I did say cosine x, but I was wrong. Okay. Sorry, sine x. And now we just integrate it till we get to the same spot as the differentiation. So we want to differentiate first so we know where to stop. So we don't, if we integrate, we might just go forever. We don't want to do that.
So you always do the other side first.
Do differentiate first so you get to 0. So you get rid of everything. Yes.
And will they always get to the same spot?
It will always get to 0 if you're working with a polynomial. Tabular integration is not as effective with like natural logs involved. So it's really most useful when you have a polynomial involved. And as, crap, why is my brain
That's not my name.
not
Try again.
Benjamin was saying earlier, this will kind of repeat in a circular pattern because it just changes signs. So negative cosine, negative sine, positive cosine, positive sine. So now we're back to the repetition, so now we just know it's going to be negative cosine again, negative sine. So this is actually all the information we need to write our answer. We just have to still write out our answer. So the way this is all organized is the top one goes to the second line of the integrate column. Okay. The second one will go to the third line. It just goes one line down, and these two are multiplying together. So x to the fifth will multiply by negative cosine x. 5x to the fourth will multiply by negative sine x. The last thing we need to take into account is that the formula had a minus sign in the middle. So what that's going to force us to do is alternate the signs. So originally we had u times v. That was positive. And then we had minus v du, so that takes it to be a negative. But if you had to repeat the formula again, the next piece would have a minus minus. So we go back to positive, negative, positive, negative. Yes.
What happens to sine?
It is not used.
And 0?
Also not used. Yep, these don't need to be used in your answer.
We feel lonely. Left out.
So now we have everything we need to write our answer. We know the integral of x to the fifth sine x would be, so we multiply everything up. X to the fifth times a positive times a negative cosine x is negative x to the fifth cosine x. And then we add the next piece multiplied out, or subtract, depending on whatever sign you get out. 5x to the fourth times a negative sign makes positive 5x to the fourth sine x. And then we multiply again. 20x to the third times a positive times a cosine is positive 20x to the third cosine x. I'm running out of room, so instead of writing side to side, I'm going to have to start going down. The next one would be negative 60x squared sine x. Next one would also be negative because we have positive times negative. So minus 120x cosine x plus 120 sine x. So this whole thing is our answer. Yes.
How do you know which the positive and negative thing?
You always start positive and
you
just alternate.
And what does that affect?
It's like you have a positive 1 or a negative 1
In front.
multiplying when you multiply.
Oh, okay.
All of this multiplies together. All of the next one multiplies together.
So the negative on the sign would be cancelled by the.
Yep, because when you multiply a negative 1 times a negative sign, makes it positive. So I know, like I said, there is still a lot of writing, but this is actually quicker than if we did the formula. Still a pain, but it's still quicker.
I like this one.
So let's do a try problem. This time I did make it a little bit more difficult to integrate. You're going to have to do U substitution when you integrate every single time. You might see a pattern develop though where you can figure out what the next one will be even if you don't actually go through the full process of integrating. We got as our final answer, help me out,
Negative x cubed over 2
Negative
times
1/2
e to the
times
negative
e to the negative 2x.
minus 3x squared over 4
It's different. It's the same thing.
times e to the negative 2x minus 3x over 4.
Finish-
Wait, no.
yeah, 6x over 8, which is
Yeah, 3x over 4.
3x over
yeah,
4.
it is everything. And then e to the negative 2x minus 3x times e to the negative 2x plus c.
good.
Impressive.
Good. And like I said, it looked like everyone got it correct, just we formatted it differently. So the last thing I wanted to talk about today is, what if we're doing one that is a definite integral instead of indefinite? And also, since I forgot on our first problem, what should I add to our first problem?
Plus c.
Plus c. It's easy to forget, especially if you've been gone for, an entire week.
You've been gone for an entire week? Where have you
So have you
been?
guys. I disappear. I don't
How
really
do you know I
exist
haven't been
when
here?
we're...
Because you haven't been here.
No. I just cease to exist when you guys leave.
No, she doesn't. I can say she too.
So this one has a natural log. This one is actually harder to do with tabular integration. It's easier to do the formula because there is a natural log involved. And what else do we notice? What's different than...
It has bounds from 2
has
to 5.
bounds. So because this is something we may have to repeatedly integrate, we ignore the bounds until the very end of the entire process. You could kind of do them in between if you wanted, but it's not as good of a way to organize your information. So we still decide what's U, what's V, what's dV. And Melinda, you were going to say what U was?
X
Okay. According to Lippitt, it's natural log. Normally U is that polynomial, so we get in the habit of picking U to be the polynomial no matter what else is going on. We do have to be careful of that.
Precise.
So du would be 1 over x.
What is e to the x considered? Exponential?
Yes, it is an exponential function.
Okay, that was my problem.
Integral of x to the third, x to the fourth divided by 4, or put a 1/4 out front. Whichever way you prefer writing, it does not matter.
Unless you're in Russia.
And then we
Alright.
just apply the formula, u times v, so 1/4 x to the 4th times natural log x minus v du, 1/4 x to the 4th times 1 over x
dx.
And now with natural log, what should usually happen?
Something cancels.
What cancels?
The x.
The x cancels out so that we can just integrate this immediately.
That normally happens with natural log?
Yep. Normally. So we get 1/4 x to the third dx. So again, I'm not even writing my bounds in right now. I'm just ignoring them completely until the very end. So now, if we need to do integration by parts again, we should, but what kind of problem, what kind of integral problem is this? What method should we use? Anti-power rule. So if we just have a polynomial, we just integrate immediately. So we get 1/4 x to the 4th ln x minus 1/16 x to the 4th. Evaluated now from 2 to 5. Now we do fundamental theorem of calculus. So we just do all our integration like we would normally if there were no bounds. And then we just do our fundamental theorem of calculus like we would normally after we integrate. So we evaluate, which one do we plug in first? 5. So we have 1/4 times 5 to the 4th ln of 5 minus 1/16 times 5 to the 4th minus, and then this entire second half has to be in parentheses because it has that negative sign. So minus 1/4 2 to the 4th ln of 2 minus 1/16 times 2 to the 4th.
You have to plug that in for every x.
Yep,
So
every
on
single x.
Super long ones.
If we had done that first problem we did, you'd be plugging in a lot of information. So we can just plug this straight into our calculators. If they were to simplify, they would probably use those logarithm rules. They'd simplify whatever this number is and then make it an exponent inside and stuff. But this one won't work out nice if you do it, so just plug it in and get a decimal.
Two to the 4th. Nice decimal.
And I just picked random bounds, so it might come out as really funky decimal, but
So when you have the number switched, if it's like 5 to 1, is the whole thing sign switched, or is it just?
yeah, you could plug it how it is right now and just make your final answer negative or positive depending on what your final answer comes out as. But yeah, basically it would just be this entire thing,
In the negative.
the negative out front. So we're getting one answer of 210.64.
I got that too.
Okay. It happens. Might just be one tiny detail. 0.64 third decimal, because we must use. That's it? Okay.
Switch it again, and it goes like 210.639.585.559.
Wait,
Overachiever.
press what?
What? Yeah, how did...
Oh.
Oh, okay. Good to know.
If you do what?
They said highlight the decimal and press enter.
Whoa.
That's
It got
really
bigger.
good to know, because we need 3 decimal places.
It's like
Um,
chemistry. Sig figs.
Homework.
No,
Oh, I was going to talk about one more thing. So yeah, if we had gone and done our original problem as an integral with bounds, you'd be replacing every single x 2 times, because we'd have to do the lower and upper bound. So we'd do this entire answer from negative x to the 5th to sine x, plug in a value, and then minus the
She's
second
hinting
year.
at something for the homework, I just know it.
No, I don't think any of the homework are quite as long as that first example.
Okay.
Just pointing it out so that it is discussed.
So page 351, 21 through 28.
So about 8 problems?
So about 3/5 of them.
Exactly 8 problems.